Two-step verification, abbreviated to TSV, is a process involving two subsequent but dependent stages to check the identity of an entity trying to access services in a computer or in a network with just one factor or secret, whilst there is no proof obtained that the bearer of the unit is identical to the owner of the unit. This is the simplest case of a multi-factor authentication, which might involve only one of the three types of authentication factors for both steps. Explanation on terms. In just technical procedures with portable units, all information contained in the unit does not provide authentical evidence about the identity of bearer and owner. Only when each step of an authentication procedure involves a set of two different and independent authentication factors provided by the bearer, then the preliminary technical verification gets extended via real authentication finally to two-factor authentication (TFA). In common one-factor authentication procedures, the name of the owner and his personal secret are formally not independent, as they get used generally in invariant coherence. This is to be taken into account especially when the personal name of the owner of the personal secret is openly displayed. Example: to provide an everyday example, an automated teller machine typically requires two-factor verification. To prove that users are who they claim to be, the system requires two items: an ATM smart card and a personal identification number. In the case of a lost ATM card, the user's accounts are still safe. Anyone who finds the card cannot withdraw money as they do not know the PIN. The same is true if the attacker has only knowledge of the PIN and does not have the card. This is what makes two-factor verification more secure. There are two factors required in order to authenticate. Note that if the ATM smart card is merely a magnetic stripe card, it is copiable. Then the process is only two-step authentication but not two-factor authentication, since the ATM is only verifying that the user knows the data encoded on the magnetic stripe and presented it in magnetic stripe form. A smart card with a chip performs a challenge-response authentication. The information transmitted from the card to the ATM is not the information required to duplicate the card's abilities. Google's two-step verification process. Google was one of the first Internet companies to introduce a two-step verification process. To access a Google service using the two-step verification process, a user has to go through the following two stages. The first step is to log in using the username and password. This is an application of the knowledge factor. The implementation of the second step requires a mobile phone or the Google Authenticator application, which is an application of the possession factor. If the user opts to use a mobile phone, he/she has to register his/her phone number with Google. When one attempts to authenticate with username and password, Google will send via SMS a new, unique code to the phone. Receiving the SMS demonstrates that the user has the phone. If the user opts to use the Google Authenticator, he/she simply opens the application, which generates a new code every 30 seconds. This code is to be entered to complete the login process. As a backup option in case the registered mobile phone or device running Google Authenticator is lost, stolen, or otherwise unavailable, the user can print a set of static single-use backup codes and store them in a safe place. Other sites offering two-step verification service. The following are some other sites which offer two-step verification service: Amazon Web Services, App.net, Apple ID, Battle.net, Bitstamp, BlueChain.info, Box, Buffer, Dropbox, eBay, ATrade, Evernote, Facebook, Gandhi, GitHub, GoDaddy, Hootsuite, Hover, LastPass, LinkedIn, Local Bitcoins, Microsoft, MongoLab, Namecheap, PayPal, SocialFlow, Tumblr, Twitter, WordPress, Yahoo Mail, Zoho, BBK. References